Good day everybody. In today's session we will learn how to integrate this scary integral. It's negative integral pi over 4 to pi over 4 dx divided by 1 positive e raised to the power of x times cos x times sine raised to the power of 4x positive cos raised to the power of 4x. Now it might look scary, but apparently it is not as scary as it looks, because this can easily be annihilated by simple substitution. So having mentioned that, let me start off with this all important assignment. Let me just take let I to be equal to this given integral. Now what I wish to do is, I would like to make the substitution let x be equal to negative x. So that would mean my dx is equal to negative dx. So therefore this original integral is rewritten as integral. I'm not going to do anything with the limits as of now. In place of dx I will substitute negative dx divided by 1 positive. X is negative x, so it's going to be e raised to the power of negative x cos of negative x. Now cos is an even function, so that stays as it is, times sine of negative x. Now this has a degree 4, so that would also stay as it is, and as I mentioned, cos will stay as it is. So this is what we have got. Now the limits, let me put in the limits. Now what happens is, when x is equal to negative pi over 4, negative x is equal to negative of negative pi over 4, that's nothing but positive pi over 4. So this is going to be positive pi over 4. Now when x is equal to positive pi over 4, negative x is negative of pi over 4, which is negative pi over 4. So this is going to be negative pi over 4. Now because of the presence of this negative sign, I can flip the limits and rewrite this as I equal to negative pi over 4 to positive pi over 4, and you got dx divided by 1 positive e raised to the power of negative x cos x times sine raised to the power of 4x positive cos raised to the power of 4x. Now what I wish to do is, e raised to the power of negative x, I can write it as 1 over e raised to the power of x. So by that we would now have integral negative pi over 4 to pi over 4 dx divided by 1 positive 1 over e raised to the power of x times cos x times sine raised to the power of 4x positive cos raised to the power of 4x. So this is equal to integral negative pi over 4 to pi over 4. I take the LCM, so this is going to be e raised to the power of x times cos x positive 1 divided by e raised to the power of x times cos x times sine raised to the power of 4x positive cos raised to the power of 4x times dx. This is what we have got. So if you had to flip this, this is equal to e raised to the power of x times cos x divided by 1 positive e raised to the power of x times cos x times dx, and of course we need to have sine raised to the power of 4x positive cos raised to the power of 4x in the denominator, and the limits are negative pi over 4 to pi over 4, and you got I. So this is taken to be as 2, this original is taken to be as 1. Now what I wish to do, I would like to add 1 with the 2. So if you were to do that, on the left hand side I will get 2 times I. On the right hand side it's negative pi over 4 dx over 1 positive e raised to the power of x times cos x times sine raised to the power of 4x positive cos raised to the power of 4x added with negative pi over 4 to pi over 4. You got in the numerator e raised to the power of x times cos x divided by 1 positive e raised to the power of x times cos x times sine raised to the power of 4x positive cos raised to the power of 4x. So this is what you got. Now adding, you get integral negative pi over 4 to pi over 4. This is going to be 1 positive e raised to the power of x times cos x times dx divided by, the denominator is going to be common, 1 positive e raised to the power of x times cos x times sine raised to the power of 4x positive cos raised to the power of 4x. Now this and this can be cancelled, so you get integral negative pi over 4 to pi over 4 dx divided by sine raised to the power of 4x positive cos raised to the power of 4x. Now what I wish to do is I would like to take cos out. So cos raised to the power of 4x comes, so this is going to be sine raised to the power of 4x divided by cos raised to the power of 4x positive 1. You got the dx there. This is negative pi over 4 to pi over 4. So this is equal to, if you had to, now 1 over cos x is equal to secant x. 1 over cos squared x is secant squared x, and 1 over cos raised to the power of 4x is equal to secant raised to the power of 4x, right? So this is negative pi over 4 to pi over 4. This is going to be secant raised to the power of 4x times dx divided by sine over cos. Now what is sine over cos? Sine x over cos x is equal to tan x. Sine squared x over cos squared x is tan squared x. So sine raised to the power of 4x over cos raised to the power of 4x is tan raised to the power of 4x. So this is what you get. So I would replace that. So I get tan raised to the power of 4x positive 1. Now I would like to make a substitution to handle this. Now before I could make the substitution, what I wish to see here is, this is an even function. When I say even function, if I substitute x, say when f of x is replaced with f of negative x, that would still give me f of x, right? Because every time I'm rewriting negative pi over 4 to pi over 4. So instead of doing that, I wish to change, because it's a little bit of work that could be cut down. So this is going to be 2 times integral 0 to pi over 4, right? Because of the fact that if I replace x as negative x, I still get the function back. So that is fine over here. And on the left hand side, I got 2 times I. So this 2 and this 2 can be cancelled, giving me I is equal to this quantity. What is that? Secant raised to the power of 4x times dx divided by 1 positive tan raised to the power of 4x. Now what I wish to do, I would like to make a substitution. What is the substitution? Let me take tan x to be equal to some p. I differentiate, I get secant squared x dx is equal to dp. So I will rewrite this as integral secant squared x times secant squared x dx divided by 1 positive tan squared x raised to the power of 2, right? So let me move to the other page. So what I've got I is equal to integral 0. I'm not doing anything with the limits. I need to set the limits. So I have secant squared x times secant squared x dx divided by 1 positive tan squared x raised to the power of 2. Now what I've done, I've taken tan x to be equal to some p. So differentiate it. I get secant squared x dx is equal to dp. So this is equal to, in place of secant squared x dx, I will substitute dp, and there is a secant squared x. I have a formula, secant squared x negative tan squared x is equal to 1. Therefore secant squared x is 1 positive tan squared x. So substitute that 1 positive tan squared x divided by, you got 1 positive tan squared x raised to the power of 2. But this can be rewritten as 1 positive tan x is p, this is 1 positive p squared divided by 1 positive tan x is p. So this is tan squared x, so you got p squared raised to the power of 2. That's going to be p to the power of 4 times the dp. Now you need to get the limits. So when x is equal to 0, tan x is tan of 0 will give you 0. So p is equal to 0. When x is equal to pi over 4, tan pi over 4 is 1. So this limits will be, this limits which were from 0 to pi over 4 will now be changed to 0 to 1, and on the left you got I. So this is what you got. So now I like to make one substitution. So what I wish to do is, I would like to, we will multiply by 1 over p squared and divide by 1 over p squared, right? So this is equal to integral 0 to 1 over p squared times 1 positive p squared times dp divided by 1 over p squared times 1 positive p raised to the power of 4. So this can be rewritten as 0 to 1 over p squared positive 1 times dp divided by, if you were to bring this is going to be 1 over p squared positive p squared. So this is easily integrable. Now I would like to make a substitution. So what is the substitution I will make? In fact, before I could start the substitution, I would like to rewrite this as p negative 1 over p raised to the power of 2. So if you had to square this, you get p squared and 1 over p squared followed by negative 2 times p. Negative 2 is an extra. So to counter that negative 2, I will have to add a positive 2. Now you will know why am I doing it like this. Followed by, in the numerator I get 1 positive 1 over p squared times dp. So I would like to make the substitution. What substitution? Let p negative 1 over p be equal to sum u. So if I differentiate this I get 1. If I differentiate this I get positive 1 over p squared, and this entire thing has to be multiplied by dp. So this is equal to du. So clearly you can see that we have obtained the numerator. So this is equal to, I'm not going to place in the limits as of now. So let's place in the values. In place of 1 positive 1 over p squared times dp, I will be substituting du divided by, in place of p negative 1 over p, I will substitute u. This as power 2. So substitute, or I should say place 2 there, and this is going to be u squared positive 2. Now the limits, what happens to the limits? The values are from 0 to 1, right? This is from 0 to 1. So if you had to take the value when p is equal to 0, what happens? This is 0 and this is negative 1 over 0. That means u will be negative infinity. So in this case it's negative infinity, and then when p is equal to 1, you get 1, negative 1 over 1, that's going to be 1. So this means u is equal to 0. So you got a value 0 there. So this is nothing but integral dx over x squared positive a squared. That's nothing but 1 over a tan inverse of x over a, right, plus c. Applying this is going to be 1 over root of 2 tan inverse of x over a. So u over root 2. Limits are negative infinity to 0. So when I substitute the upper limit, I will get 0. I substitute the lower limit, it's negative infinity, so you will get negative pi over 2. So negative negative positive, so what you have, you got 1 over root 2. Negative negative positive is going to be pi over 2, so which is nothing but pi over 2 times root of 2 square unit. I need to just say units. I don't want to say square units because I just completed an algebraic problem. So that's why the square is on my mind. So the value is pi over 2 times root 2 units. So if you were to place in the final solution, you can just state it as follows. So therefore, integral negative pi over 4 to pi over 4 dx divided by 1 positive e raised to the power of x times cos x times sine raised to the power of 4x positive cos raised to the power of 4x. This is evaluated to be as pi over 2 times root of 2 units. So just to complete that result. So this is a beautiful question, and enjoy your day everybody. Thank you, and please like, share and subscribe to our channel. Enjoy your day.